Hello, everyone. My name is Raul Jordan, and I'm one of the developers working on Arbitrum Stylus, a new technology that lets developers write smart contracts in Rust and other programming languages, making it a lot more efficient, cheaper, and enabling things that just weren't possible before on EVM chains. Arbitrum Stylus is a fully interoperable environment for developing smart contracts with EVM smart contracts. It enables you to do awesome things such as writing code in Rust and being able to talk to Solidity contracts just as you would normally via ABI calls. This enables support for adding all kinds of new languages into Arbitrum chains, not just Rust, uncovering a ton of amazing possibilities. In this presentation, we're going to be going over how to deploy your first Stylus program and walk you through the tools and the process via which you can actually get something deployed on testnet today. So the question that we get is, how is this possible? What exactly is underpinning Arbitrum Stylus? And the answer is this amazing thing called WebAssembly. So WebAssembly is a standard for the browser that has risen over many years that enables developers to write code not just in JavaScript, but in other languages, such as Rust and C++, and run them in the browser. In the past, developers had to use JavaScript to get everything done. But as time went on, web standards committees and developers that created WASM, they created the standard so that you can actually do a lot more. So now on the web, every time you see websites that have heavy processing, they leverage the power of WASM. And we're bringing that technology to Arbitrum today. It's not only faster, but it's incredibly cheaper and enables a lot more developers to come in and write smart contracts. For example, if we wanted to implement the catch-hack hash function in Rust, we can see almost a 73x improvement in speed, and that will also translate into costs. We can do all kinds of amazing things, such as generative art, new cryptography, awesome new precompiles included in Arbitrum, you name it. The best part is that it's incredibly minimal to get started. With a simple entry point using Arbitrum Stylus, you can develop all kinds of things just in pure Rust. However, not only do we provide this minimal entry point, but we have also released a Stylus SDK, which is a Rust SDK that gives you really nice types and abstractions around Ethereum types. So you're able to do things such as make contract calls, interact with storage, interact with common types that are actually backed by Ethereum storage, which makes it super easy to translate your programs that exist in Solidity into something like Rust. WebAssembly has a ton of support from the community, and not just in crypto, but also many languages are in production already with WASM, and many are also stable for production use, and the list goes on and on. Not only are these languages available to use with Stylus to some extent, as you can add support for them, but you don't need to get permission from us to add that support. It's pretty simple to add support for a new language in Stylus, and as time goes on, we'll be releasing more tutorials on how to do that. The awesome part about writing programs in Rust on Arbitrum chains is that you get access to an incredible suite of open source community packages and crates that accomplish awesome things, such as this generative art crate in Rust that can enable you to do NFTs on chain in ways that weren't possible before. Linear algebra libraries let you do advanced math and fancy things that just are too pricey to do in Solidity. So without further ado, let's get started. First things first, you're going to need to install Rust. So on the website, there's a really awesome installation guide that works for pretty much every operating system. So I can do this, and I already have Rust installed. The process should take you just around a few minutes. The next step that you're going to need to do is add support for the WebAssembly compilation target in Rust. So you can do that here once you have Rust installed with rust-up target add wasm32 unknown. The next thing that we're going to do is, now you have Rust installed, you're going to have access to this tool called Cargo. So Cargo is this command line tool that all Rust projects use to set up the project, to build it, to test it, and to deploy it. With Cargo, you can also install packages on your computer that are Rust packages that people have built. We call these crates. As part of Stylus, we have also released a crate called Cargo Stylus. It lets you develop and build new Stylus projects from scratch using Cargo. And here's how you can easily get it. All you have to do is type cargo install, cargo-stylus, and you'll get access to this crate locally. So the next step is, we're going to be figuring out, okay, what are we actually going to be building today? So today we're going to be implementing this simple Solidity contract in Arbitrum Stylus in Rust. So this counter contract is a very common example, typically used as a hello world example for Solidity developers. It's a small contract that has a single storage variable called number, and we can update this number via a public method and increment this number. We can also read this number, obviously, from storage. And by interacting with it via transactions, we can actually mutate the state of the chain, and we can do interesting things from here. So we're going to be porting this over to Stylus using the Stylus SDK written in Rust. So the first thing you're going to need to do is you're going to be able to do cargo stylus new, and we're going to call this project showcase. This will initialize a simple project from a template that you can then open in your favorite IDE. We highly recommend using VS Code for this because it has some of the best support for writing programs in Rust. We're going to add our project to the workspace, and you can see I have it here on the left. What I'm going to do here is I'm not going to take any shortcuts. We're going to be writing our own entry point and everything from scratch using the SDK. And you'll be able to see how we can turn this counter.sol into basically a counter.rs file in Rust. Awesome. So let's actually open this up. Great. So now we basically have an empty file here in Rust. So how do we actually get started? What are the first steps to actually building this? So when you clone this, when you initialize a project with Cargo Stylus, you get access to a full-fledged Rust project that already set up for you. You get access to the Stylus SDK as a dependency, and you get access to a few other neat things that you can use. So the first thing we're going to do here is we're going to be importing the SDK. The next thing we're going to do is the SDK. Actually, when you import, the basics of the SDK inside of Prelude, you get access to a lot of cool things that let you set up your entry point. So the first thing we need to do is basically set up our counter.sol entry point. And the way we're going to do that is we're going to use this keyword called sol storage. So with sol storage, I can actually define my own entry point, and I'm going to define it as a Solidity struct. I'm going to be calling it counter. And it's going to have a uint256 called number in it. This fancy word, sol storage, will actually translate any Solidity code that's inside of here, such as structs, into Rust equivalent representations that are backed by storage trees and have all the fancy things already there for you, so you don't need to deal with nitpicky stuff such as Solidity storage slots. Great, so now that we defined our struct, we're going to actually implement some methods on the struct. So just like we had set number and increment, we're going to be doing the same thing here. The way we're going to do that is we're going to be defining a Rust implementation of the counter struct. And the Stylus SDK requires that you mark this as an external implementation. First, we're going to be defining a method that gives us the number that's contained within the entry point. So we're going to take in a reference to the counter struct, and we're going to be returning a result, which is a uint256 and an error type. So currently, the error type is just a byte slice, a vector of bytes in Rust, and that gives you flexibility over how you want to encode your errors. You can put strings in there, turn them into bytes, but it's a very common Rust idiom to return result for functions that are fallible, for example. In this case, this function cannot fail, but we're going to be able to return basically OK, and we're going to be able to do self.number.get. Awesome. So this will get the number actually from the storage slot in the Arbitrum chain, and it will actually return it to the caller. The next function that we need is a function that will update the number. We're going to be calling the set number. And because this function actually mutates the state, in Rust, we need to use the mute keyword to indicate that this function requires a mutable reference to the counter struct. We also want the person to be able to pass in the new number that they want to override in storage, right? And in this case, if this succeeds, we're just going to return void. Awesome. So what we're going to do here is we're going to be doing we're going to be fetching the number, self.number, and we're going to be setting it to this new number. Then we're going to return OK. Awesome. So we have one final method, which is increment. And it's going to return the same signature in the return type, which is just, if it succeeds, it succeeds. And here, what we're going to do is we're going to be actually pulling up the number from storage. And we're going to be updating the number in storage. At the moment, it's a little bit clunky that you have to kind of declare a bunch of variables to be able to do these load and storage manipulation options. But it will get better over time as we improve the SDK. Here, what we're doing is we're loading the actual number, and we're actually updating the number at the end. So one key question compared to Solidity's programming model is, hey, are these get and sets actually doing ststores and sloads each time I invoke them? And the answer is that by default, the Stylus SDK actually comes with a cache, an in-memory cache that will load all these things and flush them at the very end of your execution to make sure that you can do things a lot faster and not get bottlenecked as much by having to interact with storage on every single interaction here. By being explicit about setting your numbers and getting them with the set and the get keywords, we avoid implicit calls to storage and things like that Solidity might do. When you do set, it's very clear that you're actually updating something in storage, which is a different model than the existing programming model in Stylus that exists different than the current programming model in Solidity. Awesome. So we have this. So we have our special program here. It does almost everything that our counter.sol does. It actually does basically the exact same thing. So the question is, how do I actually interact with this? Is this, can I talk to this like a normal smart contract? And the answer is yes. So Stylus programs are actually fully EVM interoperable if you use the Stylus SDK. What that means is that I can actually export the Solidity ABI for this contract by doing cargo Stylus export ABI. And you can see here, the cargo Stylus tool will try to build my project. Oh, looks like something went wrong. So what happened here? Well, there's a few more things we need to define at the top of the file if we actually want to support the Stylus API. So we want to do a few interesting things here that let us basically interact with this program and do interesting things such as exporting the ABI. You notice here that we don't have a main function. Typically in Rust, projects end up always have a main function. It's a requirement for basic execution of Rust. However, because Stylus programs are just kind of WebAssembly programs that are deployed on chain, they don't necessarily have a main function. Instead, this entry point function that we declare on line 6 will actually, will transform itself into something like a main function for WebAssembly. So we have to do a few things near the beginning to make sure that we tell the project that, hey, this is not this is not executable like normal Rust code. This is a kind of a special program. So what we're going to be doing here is we're going to be declaring a global attribute. So what this says is there is no main function unless I have this feature enabled called export ABI. So actually, if you want to export your ABI, you'll be able to execute this contract and actually get the ABI out for your program, which is really cool. So let's give that a shot again. Let's try to do an export ABI once more. Oh, interesting. Looks like we're missing something as well. So it looks like we're missing something called alloc. Great. So what does that mean? So we want to keep Stylus programs as small as possible. And with Rust, you get access to a standard library, which has access to a lot of fancy things, but a lot of that is bloat that we don't necessarily need in our program, right? We also want to make sure that our memory allocation is really efficient. So the Stylus program template comes with this global allocator that you can use that is actually a lot more efficient and cheaper to use than the normal Rust allocator. And it's actually a really good choice for WebAssembly. So what we're going to do here is we're going to be declaring this global allocator, essentially. And we're going to be using an external allocator. looks like I might have messed up on a few parentheses here. Let's take a quick look. All right, cool. So now we should be able to export our ABI. And here you go. When you export the ABI, you get access to this beautiful interface called iCounter, which is just a Solidity ABI. So that means that anyone can talk to my contract using this ABI and interact with it via Ethereum transactions. Even though it's a Rust program, it's fully interoperable with the EVM. And that's really something special that we haven't seen before in blockchain technology. So this all looks great, but how do I make sure that this actually works? And moreover, how do I actually deploy it on chain? So the Cargo Stylus tool comes with a bunch of utilities to make this easy for you. One of them is the ability to obviously initialize a project and export the ABI, but you also get access to being able to verify that your program works and that it can be deployed on chain. So we get access to this really nice command called Cargo Stylus check. This command will actually build your project to WebAssembly, and it's going to actually check that it will succeed a deployment on chain, right? Not every project will succeed on chain because, for example, WASM programs have to fit under the 24 kilobyte size limit for smart contracts on Ethereum. And this limit is actually compressed WASM, so you get actually a bit more leeway. You can see here that my program is only 8.5 kilobytes compressed, and that actually succeeds a deployment on chain. That means that I can confidently send a transaction to deploy this, and I can get this working on testnet. So let's take a look at how we do that. So what I'm going to do here is I'm going to type in cargo stylus deploy, and I'm going to be passing in a key, a file that contains my private key for testnet. And from here, I can actually deploy my programs. Let's give this a shot. Awesome. So it's also checking that my deployment will succeed, and it's sending the transaction. So deploying programs on chain for Stylus requires two transactions. The first one is to actually just put your code on chain. The second one is to actually activate your code on chain. This activation is really nice because it compiles the program internally in the node and allows anyone else to call it and never have to do that again. So once your program is activated once, you don't need to do that again. And I can see here my transaction fees for deploying this program. On the testnet, it's of course super cheap. We have a very low base fee. But once again, the amount of gas that is used will be going smaller and smaller over time. So great. So our program is out there. We have that it's been deployed to a special address called 0xd1d63. So this is the address that I deploy my program at. So how can I actually interact with this? Well, we can actually use any Ethereum developer tools that you're comfortable with to interact with your program. In fact, in the showcase, every time you initialize a project with Cargo Stylus, you get access to an example of how to interact with your program via Ethers RS. Ethers RS is a common utility belt library for interacting with Ethereum programs. This is nothing specific to Stylus. Remember, our programs are fully EVM interoperable. That means that we can call them normally using any Ethereum tool you prefer. If you like to use a wallet such as MetaMask, if you want to use something such as Ethers.js in JavaScript, if you want to try something such as Foundry and Forge and Cast, you can try that out. Your program has an ABI that we exported, and we also conveniently located it here. So this example, what it's going to do is it's going to use Ethers RS to basically interact with my program and call one of the functions. It's going to call set number and the increment method of my Stylus counter program that I just deployed on chain. So what I need to do that is I need to define an environment variable called Stylus program address. And I'm going to put in the address of my deployment. I'm going to put in the path to my private key for the testnet deployment as well, which is just a file. And the last thing I need is the RPC URL, which is just the RPC URL of the testnet for Stylus, which is publicly available. Next, I can run my program by doing cargo run example, and I'm going to be doing cargo run example counter. And I'm going to pass in my computer architecture so that it knows that I'm not building this for WASM. I'm building this for my local computer architecture, which in this case is an Apple M1 computer. So You can find your own target architecture by typing in rust c -vv, and you can see it here. It's my host architecture right here. On Linux, this will be different. So I'm going to run my example, as mentioned. And this is obviously, it's going to build the example. It's going to compile a bunch of the dependencies that the example has. But this shows you how you can interact with your program on chain. All right. You'll notice if you're not a Rust developer that Rust sometimes has long compile times, but there are many ways to get over this. And typically a long compile is only the first time that you actually compile your Rust program. So we're almost there. Okay, awesome. So it sees that my counter program on chain has a value of 0. Obviously, nobody's called that number, nobody's incremented that number. And I just incremented it via a transaction. So we actually invoked the increment method here of my program. And I can run it again. And now it's 1, and I can increment it to 2 via a transaction. So I was just able to interact with the Stylus program on chain using Cargo Stylus, using Ether's RS, and you can keep your whole smart contract development stack in Rust. You don't need to switch over to context switch between something like Hardhat or Foundry or Solidity or whatnot. When you develop things in Stylus, you can focus on what matters, which is your code and your performance. So we just deployed it. Cool, our counter is up. And that was it. So we went from having nothing in the beginning to developing our own version of counter.sol written in pure Rust using the Stylus SDK. We compiled this to WebAssembly. We deployed it on chain, and we were able to interact with it. And hopefully this gets you started. If you want to learn more about Stylus, I would highly recommend going to the SDK repo. There's an incredible amount of documentation that's been put into understanding how to develop Stylus, what features you get access to. And this quick start right here in our documentation portal gives you access to all the information that you need, even being able to get faucet funds to run on the testnet. So that'll be all. Thank you, everyone. Hope you enjoyed the presentation, and we'll see you next time.